In this problem, we're being asked to name an organic compound. Now, we are given two diagrams of this compound. They are actually of the same chemical, even though they look very different. On the left-hand side, we see a condensed structural diagram that shows us all of the carbons and hydrogens. On the right-hand side, we have a line diagram that only shows us the apexes where you have carbon bonds. They are both the same, however. First thing we always have to do when we're naming a compound is we have to find the parent chain. Now, the instinct sometimes is, oh, it's just going to be a straight line across, or if it's a line diagram, it's going to be a zigzag across. But that's not the case. You have to look carefully and see where is the longest possible chain. So we can count up, okay, 1, 2, 3, 4. Is there a longer chain? Well, we could also count 1, 2, 3, 4, 5. That is a longer chain, but the best one is 1, 2, 3, 4, 5, 6. And we can see the same thing here through the line diagram. Apex 1, 2, 3, 4, 5, 6. So that is going to be the parent chain here, the longest possible chain. Now, since it is a 6-carbon chain, 6 means it will be hex something. So we know the parent chain is going to be some sort of hexane. Then we also have to look at the branches. Now we can see that we have 3 branches here. One here, one here, and one here. Same thing on the line diagram. Just looks slightly different, but it's in the same locations. Now, all 3 of those branches are single carbon. Since it's 1 carbon based, each of the branches is going to start with meth. So the main chain, the parent chain, is hex-based. The branches are meth-based. What we have to do is we have to count up the location on the parent chain where the branches are. And there's actually 2 different ways we could number this off. We could go from left to right, in which case it would be 1, 2, 3, 4, 5, and 6. Or we could also go right to left. 1, 2, 3, 4, 5, and 6. Now, the one that we want is going to be the one that is going to minimize the numbers as much as possible. What I mean by that is that we need to indicate for each branch which carbon it's located on. We need to say if it's carbon 1, carbon 2, carbon 3, carbon 4, or 5 or 6. In order to do that, we have to put a number in front of them. We want those numbers to add up to the smallest possible. So when we go the left to right way for this molecule, we get 1 branch at carbon 3, and we get 2 branches at carbon 4. That gives us a total of 11. When we go from right to left, we have 2 branches at carbon 3 and 1 at carbon 4. That gives us a total instead of 10. So in this case, that means that the purple numbering scheme is our preferred numbering scheme, because that's going to give us a lower number for the branches than the blue one would. So now we have all the information that we need in order to name this compound. First thing we are going to do is we are going to name off all of those different branches. Now, nice thing is all of them are methyl branches. So we can build off of that. We have 2 branches at carbon 3. So we're going to write 3, 3, and then 1 at carbon 4. Numbers of the same type go with the same branch. We always separate them by commas. Whenever we transition from numbers to words, we add a dash. So we have 3, 3, 4. There's 3 of them, so we're going to put a tri prefix. They each have 1 carbon, so we put the meth prefix. And these are branches, so we add the ul suffix. So we start off with 3, 3, 4 trimethyl. That indicates that there are 3 carbon branches, 3 single carbon branches on carbons 3, 3, and 4 of the parent chain. And then it's hex for the parent chain because there's 6 carbons in total, all of which have single bonds, so it ends in ane. So this compound's name would be 3,3,4 trimethylhexane.